Maybe this agent, is a tutor to the CEO. Maybe there's a tutor for all of our employees. These digital AI workers, we call them AI agents, are essentially like digital employees. And just like digital employees, you have to train them. You have to create data to welcome them to your company, teach them about your company. You train them for their particular skills depending on what function you would like them to have. You evaluate them after you're done training them to make sure that they learned what they're supposed to learn. You guardrail them to make sure that they perform the job they're asked to do and not the jobs they're not asked to do. And of course, you operate them, you deploy them, provide them energy from Blackwell, the AI tokens from Blackwell, and they interact with other agents to work as a team to solve problems. Well, you're going to see all kinds of different agents, and we created several things to make it easier for the ecosystem to be able to build AI agents for companies. NVIDIA is not in the service business, and we don't deliver final product. We don't deliver solutions. But we do deliver the enabling technology to make it possible for the ecosystem to create AI, to deliver AI, to continuously improve AI. The AI agent lifecycle libraries. The lifecycle platform is called NeMo. And NeMo has libraries for each one of the stages that I mentioned, from data curation to training to fine-tuning to synthetic data generation to evaluation to guardrailing. And these libraries are integrated.
We chose Shopify because for us it was the quickest, easiest, and most seamless method of getting our business online as quickly as possible.
Have an idea for a business, but no idea how to get started? Whether it's secure transactions, running analytics, or selling your products on social media, with Shopify, you have everything you need to supercharge your business, all in one place. With the right tools in hand, you can focus on what you do best, like coming up with your next big idea.
Integrated into workflows and frameworks all over the world. We're working with AI startups, service providers like Accenture and Deloitte, companies all over the world to bring this to all of the large companies. We also work with ISVs like ServiceNow so that they can create agents that use ServiceNow. Today, you use ServiceNow by licensing the platform, and your employees interact with the ServiceNow platform to get assistance. In the future, ServiceNow will also provide a large number of AI agents that you can rent, essentially digital employees that you can rent to help you solve problems. We're working with ServiceNow, we're working with SAP, Cadence, Ansys, companies all over the world, Snowflake, companies all over the world, so that we can all build agents that can be helpful to you in driving productivity in your company. Now, these agents are able to understand, reason, plan, take action. And these agents are collection or systems of AI models. It's not just one AI model, but a system of AI models. And NeMo helps us build those. We also create pre-trained AI models that we package up in what is called a NIM. And so these NIMs are microservices. They're basically AI packaged. In the old days, software was packaged in a box, and they come delivered with CD-ROMs. Today, AI is packaged in a microservice, and inside, the software is smart. You could talk to the software. And you can talk to the software because it understands what you mean, and you can connect the software with other software. You can connect this AI with other AI. And together, you could create, essentially, an AI agent. So this is the first thing. Let me give you an example of some of these agents.
Agentic AI is transforming every enterprise, using sophisticated reasoning and iterative planning to solve complex, multi-step problems. AI agents help marketing campaigns go live faster with instant insights, helping optimize supply chain operations, saving hundreds of millions in costs, and reduce software security processes from days to seconds by helping analysts triage vulnerabilities. What makes agentic AI so powerful is its ability to turn data into knowledge and knowledge into action. A digital agent, in this example, can educate individuals with insights from a set of informationally dense research papers. It was built using NVIDIA AI blueprints. These are reference workflows featuring NVIDIA acceleration libraries, SDKs, and NIM microservices that help you rapidly build and deploy AI apps. The multimodal PDF data extraction blueprint helps build a data ingest pipeline, while the digital human blueprint provides smooth, human-like interactions.
Hi, I'm James.
A digital agent ingests PDF research papers, including complex data like images, charts, and tables, and generates a high-level summary delivered through an interactive digital human interface.
What an exciting breakthrough in weather forecasting. The development of Cordif, a new generative model, is a significant step forward in accurately predicting weather patterns. By combining a UNet regression model with a diffusion model, Cordif can
James can also answer questions or generate new content based on the papers. NVIDIA AI gives enterprises the power to automate processes, tap into real-time insights, and enhance workflow efficiency.
AI agents. 3 parts: NEMO, NIMs, and blueprints. These are all references. They're available to you in source form so that you could use it as you like and build your AI agent workforce. None of these agents can do 100% of anyone's task, anybody's job. None of the agents can do 100%. However, all of the agents will be able to do work for 50% of your work. This is the great achievement. Instead of thinking about AI as replacing the work of 50% of the people, you should think that AI will do 50% of the work for 100% of the people.
We also had Miyoshi-san actually talk about personal AI agents, and I think this is going to be a really big theme for next year.
Que tipo de negócio você possui?
Eu vendo online no modelo de negócio chamado dropshipping, onde eu vendo das minhas lojas virtuais sem ter que gastar nada em estoque.
E quantas lojas você tem?
Eu tenho 5 lojas agora.
Quanto de dinheiro você faz?
Eu faço por volta de $200 mil.
Isso é lucro ou é venda?
Isso é no bolso.
Como é que alguém pode ganhar dinheiro como você no Shopify?
Vendendo online no mundo inteiro em dólar.
Como é que faz para eu começar com o Shopify?
A primeira coisa que você tem que fazer é ter uma loja online. Produtos para que você possa vender. Se tu não tem produto, você não tem business. E é isso que eu me proponho. Eu monto uma loja virtual com produtos escolhidos por mim e pelo meu time, que você pode vender no mundo inteiro em dólar e você não precisa nenhum dólar de estoque.
Parece até bom demais para ser verdade.
Não, mas realmente é muito bom. Por quê? Porque quem me paga é o Shopify, não é você. Se você fica com a sua loja por mais de 3 meses, o Shopify me paga. Então, se você tem sucesso, eu tenho sucesso. Se você não tem sucesso e desiste no meio do caminho, eu não sou pago.
O que o meu sucesso significa?
É você vendendo todos os dias, por pelo menos 3 meses. Você vendendo todos os dias.
Você tem sucesso quando eu vendo por 3 meses.
Exatamente.
Então, para quem está assistindo agora, se eles clicarem aqui, eles vão ter a loja deles por $1?
Exatamente isso.
think agents. I think you mentioned about enterprise AI agents. Definitely, I support that. I'm excited about that. But also, I think personal agents will really come to every one of us. Bill Gates said the PC on every desktop. Steve says, smartphone on every your hand. I think now we should say AI agents to everybody. So each of us should have our own personal agents.
That's right.
That will help make our plans for trip, vacations, right? Educations.
And it follows you your whole life.
Yeah, yeah.
Could you imagine an AI agent that knows you your whole life?
Exactly. Our grandkids, they grow up with an iPhone from, age 1, right? They talk, and every time they see some picture, they do this, even with a still picture, right? Because they are born that with 2 fingers, they think, every picture can be blown up.
In the future, they'll see a picture, they'll talk to it.
Right, they talk.
Yeah, they'll hope it talks back. You can ask a
they
question.
will have their personal agent since the age of 1. And their personal agent, like your, second body, see you, grow together with you, knows everything. You're sick, your health.
Your tutor,
Yeah, yeah,
since you were a child.
exactly.
Yeah, remembered everything that you read, remember everything that it taught you, right?
Exactly.
Yeah. Your personal Aristotle.
Totally. Digital twin,
Yes.
I think that is really coming.
Now, remember how I said personal agents are going to be a theme for next year? If you haven't been playing around with ChatGPT's memory feature, you really do need to see exactly what information it has on you. For example, it has that my name is Andrew, I'm a male, I live in London, and I eat healthily and run an AI-focused channel. It does have a lot more information than that, but this allows your interactions with AI to be completely different. And this is going to be a consistent theme in 2025. Now, one of the prompts that has actually been really cool was this prompt that has been going viral. It says, ask ChatGPT, from all our interactions, what is one thing that you can tell me about myself that I may not know about myself? And I think this kind of interaction is going to completely change the game for personal AI. Now, for those of you who don't know who this is Mustafa Suleyman. He's the guy currently leading the head of AI at Microsoft, and he's actually focused on building Copilot into a personal AI that can interact with you in a variety of different ways. And I think this is going to be the next AI that takes over a lot of industries.
We have the browser for distribution, we have the search engine for content, we have MSN for news, and now we have the consumer Copilot, which is trying to produce this really conversational, fluent AI companion.
Which is a search engine, really.
Yeah, I mean, you could think of it as a search engine, but I think it's going to evolve way beyond a search engine. I mean, this is going to become a lasting, meaningful relationship. People are going to have a real friend that gets to know you over time, that learns from you, that is there in your corner as your support. I prefer companion.
Companion, okay.
Which is also aspirational. We're not quite there yet. But it's basically getting at this idea that, these AIs are really going to live life alongside you. I mean, they're going to, it's not just a tool.
Right.
This is something that is going to end up forming a lasting, meaningful relationship with everybody over time. It is going to be your teacher. It is going to be your medical advisor. It is going to be your support network. And ultimately, it's going to take actions on your behalf. That's what the agentic piece is getting at.
Pyrexia claws at my mind.
With that, I'm very, very excited to welcome John Schulman to the stage. John is one of the co-founders of OpenAI and the creator of ChatGPT. Please welcome John. John, thank you so much for being here.
Pleasure to be here.
So there are a bunch of questions I'd love to ask you about your work at OpenAI. But before we dive into that, can you tell us a little bit about how you got excited about AI in the first place?
I used to read a lot of sci-fi as a kid. I liked Isaac Asimov's books and Werner Vinge.
Yeah.
And I remember picking up The Singularity is Near by Ray Kurzweil at a garage sale once, and looking at all the nice scaling plots, like how Moore's Law and all of its variations. So, and then I did some projects as an undergrad in doing things with machine learning. Like I worked on transcribing handwriting into LaTeX for some class, and that was exciting to me.
You also did some physics projects, right?
Yeah. Oh yeah, I did an undergrad in physics.
Nice. And so that led you to do a PhD in machine learning, right?
Yeah.
You weren't always working on language models, right? Can you tell us about the kind of work you did in grad school?
Yeah, I started grad school in neuroscience, but then I ended up switching to robotics, to a machine learning group, Peter Veal's group that worked on robotics. And so I worked a bit with the robots, the PR2, Personal Robot 2.
Yeah. Cool. So we all know that OpenAI does great research and builds great products. But OpenAI didn't start out that way, right? It started out purely focused on research, right? Can you tell us about that transition? What led to the decision to do both?
Well, we were interested in releasing some kind of product or releasing something to the world from the beginning, but we also didn't want to go too far out of our way to build a product. So we had there were some ideas being tossed around, but nothing quite came together. And we wanted to raise more money, and it was kind of, even though our structure didn't require us to make money immediately or be profitable, it seemed like we were going to be able to raise more money if we actually had some kind of product out there. And also we felt like it's nice if your research actually connects to the real world instead of just being kind of, I don't know, just having, just being like publishing things and putting together demos.
Yeah. And so your first product was the API product, right? How long, once you guys decided to start building products and shipping that, how long did it take to decide on building an API? Were there other ideas you considered?
Yeah, we had some other ideas. A lot of them were more like domain-specific applications, like doing translation. So after GPT-3, we knew that these models were impressively smart, and there must be something you can do with them. So we ended up thinking about a bunch of natural language processing applications, but at the time, we were thinking that the model wasn't quite good enough at anything to be useful by itself, so we would probably need to fine-tune it and build it, make it really good for a specific application. But I think then there was the other, I actually don't think we could have succeeded with one of those products because it would have required building up a ton of domain expertise and really digging into that domain, and it would have been, it would have required a lot of work that's separate from our main research. So the nice thing about an API is it's just basically taking the thing that the research team has built and commercializing it directly, as opposed to going and building this whole other product that's separate from what the research team is doing.
Were you deterred at all by the fact that there were other AI APIs out there? Other companies have tried building AI APIs, but none of them had been a huge success.
A little bit. That was definitely a concern, that there were some other APIs like for object recognition and vision, and I think some of them were moderately well used, but they weren't spectacular products. So we had some concerns about that, and I think in retrospect, those concerns were warranted because I'd say the original model we released the API with wasn't good enough for most people. I mean, it was a pretty small business for a while, and I think it only, the model started to get good enough only in the last year and a half or so.
So it wasn't an overnight success. When did you realize that it was going to work out, that the API was, the right choice, or that it was going to work out?
Well, I think you could have looked at the trends and predicted what I just described, that maybe the initial model wasn't good enough, but some future models would be, and like serving models seemed like a generally useful thing to do. So I would say the API only saw a lot of growth in 2022, just after we had the GPT 3.5 base models coming out, and then we sort of had a pretty steep growth curve. And then after ChatGPT itself made the API a lot more popular because a lot more people got excited about language models in general.
Now, before we talk about ChatGPT, let's talk about scaling. This is a distributed systems event in some extent. We all know OpenAI uses a huge amount of compute. And actually, I think OpenAI was perhaps the first to really go all in on scaling. Where did that belief in the importance of scaling models and compute come from?
The idea that bigger models are better was a bit in the zeitgeist, that people had produced the best benchmark results with fairly big models. And, but I guess it wasn't, and I would say the founding team of OpenAI was leaned more towards this aesthetic of scale up simple things rather than trying to build some complicated, clever thing. Like, we definitely believed that simple things that are doing the simple thing right was tended to win in machine learning. But I would say for scaling, it's not, scaling looks easy when you see the final result, or it looks obvious when you see the final result that like the curve goes up and to the right, but often there's a lot of complexity in getting there, and you have to say, I mean, there's all the systems, just doing the engineering is very difficult to get something that's actually performant at scale, and then there's usually all these little details, like you have to scale your learning rates just right, otherwise you get worse results with big models, and you have to scale your data up along with the model size. So I'd say that it took several years to figure out what were the right recipes for scaling things.
Yeah. Now, we talk about scaling as if it's one thing, but there are many different dimensions you could scale, right? The amount of data, the size of the model, just the amount of compute you put into it, maybe other things as well. Is it obvious which ones matter and which ones don't?
Well, it's usually not completely obvious. I mean, model size and data are the two biggest ones, but then you usually have a lot of hyperparameters that have to be scaled properly, and it's you have to do a lot of science to figure out how to scale them.
Yeah. So can you share some intuition about why scaling is hard? Like, why aren't we using much? What's stopping us from using, 70 trillion parameter models today, or even bigger?
Yeah, I think a lot of that is about, well, it's about compute efficiency. Like, you can, so now we know you can train a small model for really long or a big model for short, and there's some trade-off, and it turns out that somewhere in the middle you get the best compute efficiency. So if you put the flops on the x-axis, you have a bunch of curves of, you draw your learning curves of loss versus flops. There's some optimal model size for getting the best performance. So I think what we have now is just using transformers and using the training recipe we have, it turns out certain model sizes are the most efficient given the amount of compute resources we're putting into it. But that's probably going to change as we start putting more compute into the training runs, and also maybe as we start to change the training methodologies and the types of data we use, we also might find that different size models end up working the best.
Do you have a sense of whether this is something with diminishing returns or not, like how far this will take us?
Yeah, I'd say often the returns diminish as you scale the current thing, but then there are other innovations that let you continue. So I guess I don't see deep learning in general reaching a plateau or anything, or hitting diminishing returns. Maybe just doing the most basic thing reaches some diminishing returns.
Makes sense. Since this is Ray Summit, let's talk a little bit about distributed systems and infrastructure. So I'm sure almost no one in this audience knows this, but early on, or maybe partway through your PhD, you actually built your own deep learning framework called Computation Graph Toolkit. Can you share a little bit about why you built that and what you were trying to achieve?
Yeah, some people might remember Theano. That was this.
Absolutely.
That was the AutoDiff framework from before TensorFlow and PyTorch. So Theano was amazing, and